Back in viewController.swift, add a new method to configure the data source. You're going to add all the logic to configure the data source in here. Before we forget, let's call this method inside viewDidLoad so that it runs after the collection view has been set up. For collection views, you use the UI CollectionView diffable data source class to create a data source. You need to maintain a strong reference to the data source, so let's define it as a stored property. This is a generic class that takes two type parameters, a section type and an item type. If you command-click on the class name and select Jump to Definition to view the class interface, you'll see that these type parameters have a single constraint on them. They both need to conform to hashable. The hashes provided by these types are used as the unique identifiers by the data source. This is really useful, and in practice, it means that nearly any object can be used to denote a section or an item. This basic app is going to have a single section, so you don't need anything complicated. Your initial reaction might be to simply use a string identifier to denote a section, but this is Swift, and we prefer types over stringly typed code. Let's create a small enum called section to define the different sections in the app. Since this type does not have any use outside of this view controller, you can define it as a nested type. You've added a member to section, main, that defines a single section to hold all of the items in your collection view. Since the compiler can automatically synthesize hashable conformance for enums, that's all you need to do. What about your items? Since the app is displaying numbers in a list, you can specify the item to be of type int. Int already conforms to hashable, so you don't need to do any additional work here either. Using these two types, you can create an instance of UI CollectionView diffable data source. To recap really quickly, what you've done here is define a data source that specifies section as the type that maps to the sections in the data, and item as the item type. Next, you need to actually initialize this class. To do that, you need to reference the collection view, which means, unfortunately, that you need to either make this property an explicitly unwrapped optional or a lazily loaded property. I prefer lazy loading, but for this example, you're going to use an explicitly unwrapped optional. Because we're going to initialize this later, let's change this to a var. Inside the configure data source method, you can initialize a data source and assign it to the stored property. As I mentioned, UI CollectionView diffable data source takes a collection view as its first initializer argument. This is how the data source knows which collection view to work with. As its second argument, it takes a closure that defines how the collection view maps the data to each cell. The closure takes three arguments: the collection view being set up, the index path of the corresponding cell, and the data to present in the cell. The logic you define in this closure is applied to every instance of data from the data source. Using this closure, you inform the data source how to take any given item of data and present it in a cell that the collection view provides. Inside the closure, the first thing you need to do is dequeue a reusable cell of the type that you desire. If you've worked with table views before, you know that you don't want to create a new cell every time, since that's an expensive operation. Instead, you want to reuse cells after they're drawn. Earlier, you configured a cell and gave it a reuse identifier, so let's use this cell to present the data. You call DQ reusable cell with reuse identifier 4 that takes a reuse identifier and an index path. We define the reuse identifier for our cell as a static stored property on the cell subclass, so we can use that. The index path is a reference to the specific cell being created. We'll cover that in more detail later on. The index path is provided as an argument to this closure, so we can simply pass it through. The call returned from this method is of type UI collection view cell. But since you want our more specific subclass, we can attempt to cast it and unwrap it using a guard statement. Now that we have the cell, we can assign the number from the dataset to the label. That's all the customization you'll be doing, and you can go ahead and return the cell. So that's part 1 of setting up a data source. So far, all you've done is instruct the data source how to set up a cell given a single item of data. To wrap it up, you need to provide the data source with its initial snapshot of data. Snapshots are instances of NS-diffable data source snapshot. Unlike the data source, it is a generic type with 2 type parameters, one that defines the section and another to define the item type. A snapshot defines its data in terms of sections and items, with sections containing a series of items. To this snapshot, you first need to add a section using the append sections method. This method takes an array of sections matching the type specified in the data source and snapshot type definition. Since you have a single section, you can provide the enum value .main as an argument. Next, you need to add items to this section. Typically, when working with data in apps, you can get the data from a variety of sources, a file on disk, the web, so on. To keep it simple here, let's just create an array of numbers to serve as our data. Here, you've used the append items to section method to add an array of integers to the section main. As an aside, when you only have a single section, you can omit this section argument from the append items method. The items are added to the first section defined. All right, with an initial snapshot defined, you can apply it to the data source. Here, you're using the apply animating differences method that takes your initial snapshot as an argument and applies it to the collection view. What does apply mean? The data source iterates over the data and passes each number along with the collection view and the index path for each cell to this closure that we defined earlier. The second argument, animating differences, defines whether you want to animate the loading of data. Since this is your initial load, you want it to appear instantly, so you pass in false. Later on, you'll look at how you can animate changes to the data. The final argument, which I got rid of, completion, allows us to pass a closure in with any logic that we want to execute after the snapshot has been applied. This is nil by default, so we can omit it altogether. Now, for the moment that you've been waiting for. build and run your app, and you should see a scrolling list of numbers. This isn't much, but it is a start. You've defined 3 key components to get to where you are now. A layout object that defines the layout in terms of sections, groups, and items. A collection view cell that displays the actual data. Each cell corresponds to a single item in the layout object. And finally, a data source that provides the data and helps set it all up using a snapshot.